right, so now we're going to finish section 1.3 by starting with page 4, the halfway point. Fact number 2, the slope of a vertical line is undefined. The slope of a horizontal line is 0. So a couple of quick examples to illustrate facts 2 and 3. Suppose you have this vertical line, x equals 3. So if this is a point, say 3, negative 4, and this is another point, 3, 2, then if we find the slope of that line, notice that the slope is equal to negative 4 minus 2 over 3 minus 3, which is the same thing as negative 6 over 0. But we know we can't divide by 0, so that's why your slope of a vertical line is undefined. Now suppose we have a horizontal line. Let's say that's y equals 5. Let's see why the slope will be 0. So consider that point, negative 3, 5, and then consider this point, which would be 2, 5. If we find the slope of that line, it's your change in y over your change in x. So 5 minus 5 divided by 2 minus a negative 3. Well, that's equal to 0 over 5, which is 0. So we know that the slope of a horizontal line is 0. Now, we want to find equations for the following straight lines. A, we want to find an equation for the line that goes through the points let me start over. We want to find an equation for the following straight line that goes through the point 1, negative 4 here and negative 1, 1. So to do that, let's go ahead and write. So we find our slope because we have 2 points. Our slope is given by, remember, it's your change in y over your change in x. Whichever one you start with, choose to be consistent. So it's negative 1 minus negative 4 divided by negative 1 minus 1. Well, that's equal to negative 1 plus 4 divided by negative 2, or 3 over negative 2. Now, we want to find an equation for that line. We found the slope, so now let's find our intercept, our y-intercept. So that's b equals y1 minus m times x1. Well, choose one of the points. I'll choose the 1, negative 4. So that will give us negative 4 minus our slope, which is negative 3 halves, times 1, which was our x value here. So now that becomes negative 4 plus 3 halves. Find the common denominator, which is negative 8 over 2 plus 3 halves, and that gives us negative 5 halves. Now you want to find your equation. So you will have y. We can write a better y. We have y is equal to, your slope is m, so negative 3 halves x minus your slope, minus your intercept. So you'd have minus 5 halves. Okay, so you have your line here. Now we want to do part B. We want to find an equation for the straight line that goes through the point 1/3, negative 1, and is parallel to the line 3x minus 4y equals 8. So we want to find the slope. So it suffices for us to take this equation that we've been given and find the slope of that line. So we have, solving for y, we get negative 4y equals negative 3x plus 8, or y, if we divide both sides by 4, we get y equals 3/4 x minus 2 So we know that our slope is equal to 3/4 because parallel lines have the same slope. So we can find our intercept. You have b is equal to -1. You remember, use your point here. So you have -1 minus 3/4, which is our slope, times 1/3, which was the x value. That equals -1 minus 1/4, or -5/4. So our equation of our line is y equals 3/4 x minus 5/4. Okay? Now, we want to, in part C, find an equation of the straight line that's horizontal and goes through the point 1, -4. Well, if that line is horizontal and it goes through this point, we need to focus in on the y value, not the x. So our equation would be y equals -4. That's it. Vertical, and just so you can see, if you plot the point 1, -4, you go to the right 1, down 4, and you want the horizontal line, so it goes through y equals -4. Okay? Now you want, in part D, you want the line that goes through 1, -4 and is vertical. Well, what is it going to be? It's going to be x equals 1. That's it. Now, what we want to do is talk about position and displacement. So, a definition: the position or displacement is a number s given by your location as a function of time. So, example 7. A police car was traveling down Ocean Parkway in a high-speed chase from Jones Beach. The car that was being pursued by the police was at Jones Beach at exactly 9:54 p.m. That here is going to mean t is equal to 9.9. And it passed Oak Beach, 13 miles from Jones Beach, at exactly 10:06 p.m., where it was overtaken by the police. Note here that 6 minutes is the equivalent of 0.1 hours. So first we want to figure out how fast was the car traveling. Well, we're going to take S to be displacement from Jones Beach and we're going to take T to be the time in hours. So we're given 2 points. We are given 2 points. They are, in terms of T, comma, S, well, 1 is 9.9, comma, 0. So that's at 9:54 p.m. We had S was 0. And we also have at 10.1, and we have 13, because that's at exactly 10:06 p.m., 13 miles from Jones Beach. Okay, so we're asked to find the speed because we're asked to find out how fast was the car traveling. So the speed, which equals the magnitude of the slope, is given by S sub 2 minus S sub 1 over T sub 2 minus T sub 1. So your change in displacement over your change in time, which is 13 minus 0 divided by 10.1 minus 9.9. That's equal to 65 miles per hour. That's how fast the car was traveling. Now, in part B, we want to find out how far was the car from Jones Beach at time t. So we know that the position, S, is given by mt plus b, where m, we just found out, is 65. B is our y-intercept. So that's S sub 1 minus m times t sub 1. That's equal to 0 minus 65 times 9.9. Evaluate that, you get negative 630, no, not 634. You get negative 643. And you should do these calculations. 0.5. Therefore, we can write out what S is. Therefore, S is equal to 65T minus 643.5. And that is how far the car was from Jones Beach at time T. So that concludes our notes for linear functions and models. Make sure you review slope and the applications here.